Welcome to today's webinar, Forensic LiDAR using 3D laser scanning technology for crash scene investigations and reconstructions. My name is Jillian Kreider. I am the TLS sales specialist here at Regal USA. I have been with the Regal organization now for almost 10 years in various marketing and sales capacities. And I have been working with the terrestrial LiDAR systems as well as the industrial systems now for the past few years.
Hi, and good afternoon, good morning, good evening, depending on where you listen to. My name is Dave Foster, some of you may know me. I was a police officer in the UK for just over 30 years, of which 16 of those was with my Forensic Collision Investigation Unit. Retired just over, coming up 4 years ago. I've had 9 years experience in deploying laser scanner, Regal laser scanners to crash and crime scenes. I did have access to scanners before that, and prior to that was active in surveying and mapping crime scenes and crash scenes. So I've seen one or two things and hopefully learned a few things as well. So part of this webinar, we should be able to pass on some knowledge with a bit of luck to you out there.
So I'm going to run you all briefly through what we're going to be discussing today during the webinar. We're going to be discussing what does laser scanning mean for law enforcement, hardware and software developments for the forensic field, showcasing some real world examples, why you would want to use LiDAR for forensic applications, and then we're going to open it up for questions and answers throughout the webinar. So that being said, if you guys have any questions, anything that pops into your head while we're running through it, submit it to the question box. Dave is going to be monitoring throughout the webinar today.
So what does it mean, laser scanning mean for law enforcement? Well, as I have been carrying out laser scanning for crime and crash scene investigations for over 9 years now. And what LiDAR offers is the ability to create a core admissible and highly accurate 3D model, which I have to say, I agree with his comments, it's far superior to any of the previous documentation methods we used to use, and in a fraction of the time, which is obviously very important. More complete, yes, and objective evidence gathering, certainly, together with auditable workflows. Some of you, and I'm certainly one of them, used to be able to use two-man total stations, which were both time-consuming and obviously required 2 people. Our laser scanner is a one-man operation, and because it's operating very, very quickly, reduces the scene times. Talking of which, reduced time surveying a scene gives us significant time savings, and those time savings are both at the scene and later on in the office. So less time needed in the field, faster a road can be opened. That may not necessarily be a primary consideration for the police, but if you consider where the funding usually comes from, it's quite important to keep everyone on board. Certainly the less time needed in the field, the faster a road can be reopened, so saving time and saving money. But very importantly, we're also looking to reduce the secondary collision risk, which we do have some stats somewhere, increases quite markedly once you get a road closure for half an hour or longer. Reduces congestion elsewhere, pollution, etc. You can go on to quite a number of scenarios. In addition, of course, we can be deployed for other uses, such as contingency planning and security mapping. So, yeah, it's a very important tool. LiDAR goes a long way in clearing scenes, as it says there, very quickly, very safely, and very efficiently. And you've got this data frozen in time. Quick. Nice little example on the right hand side of a vehicle crashed into a telegraph pole. We've got the crush vehicle with a colour depth map applied to show where the crush pattern occurs, together with a scanned example of an exemplar vehicle which is overlaid onto it to illustrate the amount of damage. So each scan position we're recording can be completed within 45 seconds, and that includes the imagery, the RGB data to apply the colour information. And this allows us to document the crash or crime scene very quickly and easily, thus helping to get roads reopened faster and to get traffic flowing again.
So when it comes to hardware developments for the forensic field, Regal's powerhouse system is the VZ400i terrestrial laser scanner. Like Dave was saying, it is the most productive laser scanner on the market, where it's able to capture both data and simultaneous imagery within 45 seconds per position at a 5mm accuracy. So with the capability of being able to collect up to 500,000 points per second, all of your projects can be captured rapidly, safely, and efficiently. So the screenshot that you guys see up in this upper right-hand corner here, that was actually captured during our training symposium last year, where one operator was able to capture over 400 scans within 8 hours. The scanner is capable of real-time onboard registration and processing, which is allowing you to register your scans together and begin your data processing while you're still out on scene, thusly reducing your post-processing time when you're back in the office. So Dave actually did a test run in the UK where it was shown that the 400i, that the Regal systems were the only scanners that were validated at the ground truth location to operate with a targetless automatic registration in a multitude of environments, in an urban, a semi-rural, and a rural environment. So this bottom picture on the slide actually is the registered point cloud at the rural ground truth location. It was 40-meter scan intervals with the automatic targetless onboard registration. So some of you guys on the webinar today are already 400i users. For those of you who are not, we have very user-friendly one-touch workflows when it comes to the scanner. So the scanner itself is a touch screen, so you can actually just hit a couple buttons and off you go. In addition to that, we've got an app that can be used for iPhone, iPad, as well as Android products. So you can actually use preset workflows, which there are some that come pre-built onto the scanner, or you can have one built by your organization that fits your needs in the forensic field that you could allow your staff to easily deploy while they're out on scene. When it comes to the scanners themselves, they are built to withstand a variety of environments. These are durable, rugged systems that can't be shaken. So you never know what you're going to run into when you're out on scene. You're going to sometimes come across rain, snow, fog, dim lighting, bright lighting. Our system is able to deal with it all. So we've tested it in a variety of environments, in inclement weather, in very cold, where we've gone into the negatives. We've had it in downpours of rain, dense fog, super high heat. We did the scan in Arizona for that was about 112 degrees Fahrenheit. And then eye-safe operation is also one of the critically important factors of our scanner, because you're going to need to be able to work the scene while there are still fire and rescue, other police, witnesses, everything still out on site, and having an eye-safe scanner allows you to safely do so.
Okay, so Regal have been supporting public safety and forensic investigations for over 15 years. It's quite reassuring to note. We started off with the Met Police in London and 2 states in Australia with the LMS Z series, 210, 420Is. Just for those of you who don't know, this is what they say used to look like. No, they still look like that now, but we don't manufacture these anymore. Things have moved on quite a bit since then. 2010, we introduced the VZ400 to the forensic marketplace. And from about 2011 onwards, there was widespread adoption of the VZ400 in the UK and in Europe. This moved into 2014 in the States. And then now from the 2017 to the present day, the VZ400i is being deployed both across the UK and Europe, in Australia, and in the United States as well.
So for our North American customers, we have a calibration field and service center located in the Orlando, Florida area. So prior to this, everything would have to go back to our factory in Horn. So for our European customers, that still is the case. But for North American customers, we actually can now check your scanner and do system maintenance while it is here in Florida. So additionally, on top of that, we do training for our hardware and software on site in our Orlando office in normal circumstances. Right now, we're doing web-based trainings, which can easily be arranged. We can hopefully come back, do on-site trainings when everything reopens up. We can also come to you. In addition to that, the calibration field is located in Apopka, Florida, which is about 30 minutes from our current office, maybe about 15 to 20 from our new office that's being built, where we can conduct annual calibration checks here with minimal downtime to you. So this is important because we can actually calibrate your system, verify that the calibration is still within manufacturer specs, so that way evidence can be corroborated by that calibration check. With our service center being here in Orlando as well, with a 2-year system maintenance, which is what we recommend for the VZ unit, we can have your system come in-house. If we have a loaner system available, as long as there is notice, we can provide a loaner system to you to help reduce your time without a scanner in the field. Time is money, getting roads open, we have to get them open quick, fast, save the community money, save people the hassle, and this helps allow do that. So in addition to our hardware, we have a strong software solution for the forensic field called RIEGL. So once you're out in the field and you've scanned, you can actually have the data set ready to use immediately once you're back in the office because of the onboard registration with the scanner. So having that data set able to come out and take it right into RIEGL, we can import, register, colorize, and plot view your data rapidly. It's a one-touch solution, very easy, just a couple buttons, off you click, and you can access your virtual scene at any time. So this minimizes the need to return to the scene. You can have other investigators take a look at the data. You can have witnesses come back and take a look at a data. You can corroborate statements. If there were sightlines, if there were obstruction. You can produce a variety of exhibits for your court purposes. You can create 2D plans. With the coordinate export tool to CAD, investigators can select up to 700 points within a point cloud to export to a 2D line drawing in under an hour. You can create video fly-throughs and everything in between within the software.
So as well as the technology of the actual scanner and the software itself, is quite a useful time to point out some of the useful tips that we've learned during our time. So obviously doing things like making sure that you have a calibrated scanner in place with batteries fully charged and such like, operating to manufacturer specification and to whatever local policy is in place at the time. We also recommend that we conduct, as Jill pointed out a couple of minutes ago, conduct checks of the calibration which can be done locally quite easily, and that you document those checks. These can become very important somewhere down the line. You never know if that is going to be the case, of course. So moving on to the scene. First of all, let's look at our approach to the scene. We're not going to rush in there with a scanner and the camera and snap and shoot away for glory. But what we're looking to do, first of all, is going to plan the documentation when you're conducting that initial scene inspection. So I've put in brackets there scan plan, and we're going to come back to this a couple of times. Hopefully we're going to record what we're doing in our field notes. And as we're checking the scene out, it doesn't really matter if it's a crash or crime scene, we're looking out for scan shadow areas. Again, back to the scan plan, we can work this out through there. Determine what resolution we're going to use, and if we need to detail any high resolution scan windows. And now is also a good opportunity to remove noise from the scene. Cops out there will recognize the evidence destruction department. It usually hangs around for quite a while, but we're not exactly blameless ourselves, and we tend to get people milling in and out of the scene as well. So this is a time that we really need to make sure that is cleaned out as much as possible. We also need to consider about our registration. So again, back to our scan plan. So good overlap is essential. That's the same with any scanning technique. You may need to do as many scans as is necessary to capture the detail, and some of those scans may only be 4 or 5 meters apart, if that. But as Jill pointed out in the slide or two ago, with the VZ400i, we can now go out up to 40 meters maximum separation and still achieve an accurate registration. Now, this is particularly useful for documenting the road layout approaches to the scene, you know, where you just need the road markings and the signs and such like. While scanning and conducting onboard registration, we have the VZI map available, so we can check that the scan coverage is up to date. And then finally, we would download the data at the scene. We recommend that the data is recorded directly onto the hard drive in the scanner. And this offers us a couple of advantages. First of all, it's the closest point of recording. It is the most reliable and robust method of recording the scan data. Secondly, this becomes the original scan information. You then download that via USB, SD card, LAN to create your master copy, and from your master you're then subsequently working on the working copy. There's not too much working going on there. This allows for redundancy and reliability of both the scan data and the imagery as well. Now, those of you who have been scanning a little bit of time will have always had this conundrum in the back of our minds. What is the resolution, the best resolution, versus how long are we going to be scanning? Some of you had the advantage where you're in the lockdown scene for days and then it didn't really matter. But big advantage with the 400i is that this is much less of a consideration. I put a graphic on the right hand side there which gives us some indications of the scan patterns and how long they would take to complete a 360 scan. But bear in mind as well, with the I-series scanners, we are obtaining the images, the RGB data, at the same time as scanning. So what this means is at Panorama 40, which is a 7mm at 10m resolution, we're conducting a scan in 45 seconds. At Panel 34, which is 6mm at 10m, that scan is done in 61 seconds, including the imagery. Some more details are available, as I say, on that graphic on the right hand side. But the result of that is that we can obtain very good and accurate results. So this is a fly-through of a scene that was recorded in a wooded area, as you can see. 15 scan positions in total, all running at Panorama 40 resolution. So that's, just to remind you, that's 45 seconds per scan position, including the RGB data. Onboard registration was enabled, all targetless. And as we fly through the scene here, we can see the RGB values have been added to the points cloud. And I think you agree this is quite a good illustration. Flying through trees is traditionally a difficult area, but the multiple target returns capability on the I-series scanners allows us to process this relatively easy. And the result of that is a standard deviation across the whole project of better than 3mm. So pretty pleased with that. Move it on. And of course, we're looking at a nice video fly through there of the scene. We could still do lots of other extracts. We're also finding over the years some important pieces of information and data needed for the courts, such as the scene at the moment of impact, which is reconstructed here on the right hand side from one particular scene, and also the scene as the vehicle's at rest. It is a lot easier to process the scene at the moment of impact, as the scene here on the right hand side, in the software than it is doing it for real out in the crash scene. And I've done that, and it takes some time to set those two vehicles back into position. So attorneys, particularly for the American market, are now beginning to request LiDAR data for court cases. Interesting development. A couple of more examples. So we're looking at plans there. This is 2D screenshots. So this is the scene recorded of a clandestine grave dig exercise. So we can actually see, having recorded the scene as it was initially found, we can see actually the depression in the ground. But we recorded or scanned the scene as the dig took place. And because of that, we now have a full data set, which gives us validated information for the end user or the end customer, if you like. The bottom slide just shows the final scan with the total excavation completed. And the beauty about this, of course, is the data we're capturing is aiding our investigation. And I'm going to show you quite a simple and demonstrative slide here, courtesy of Gwent Police back in Wales. How very bad of me. Vehicle into a tree. Those of you who look at crush damage analysis will look at this and we can tell you equivalent current speed is around about 60 miles per hour, which is not surprising. By simple overlay of a bright outline, we can illustrate where the crush profile is measured to. And then finally, overlay a scan from a undamaged exemplar vehicle to show what it should have looked like had it not crashed into a tree. Many thanks to Gwent Police for sharing that imagery with me. Thanks.
So with the court diagrams that Dave showed you, you guys could obviously see that there's a variety of view types that were out there and available. So with RIEGL, view types are critically important to help find both seen and the unseen information in your scene. So here we have two data screenshots of a crash scene. So the left-hand side, you guys can see a true color, while the right-hand side shows the same scene in reflectance. So in the true color, up right where I'm hovering my cursor, you guys can see the slightest bit of a tire tread mark. However, if you come in and you come into reflectance, you can see the entire markings of the tire tread of when they started to actually apply the brakes. So if you are using LiDAR for forensic purposes, it's important to understand that you are going to need to occasionally look at different view types to see if you can find the information that you need.
So a similar example here, nice colorized scan data. Obviously, there's people milling about in this area. This is a scene demonstration. So just highlights my point a few slides ago of make sure your scene's clear. But this is a colorized scan, as you can see. But if we look at it in reflectance mode and interrogate the data in another manner, we see this pair of curved tire marks coming out of the car park. Couldn't see them at all in the RGB data, which is really useful to be able to examine the scene in a different way. So, yeah, we know the human eye is the best lens that there is. It's far better than any camera, but it's quite useful to be able to back up this information with the analysis of the data. We're not harming the data, we're not fiddling with the data in any way, we're just asking the software to interrogate it in a different manner.
So on that note, we're actually going to dive in and show you guys some real world examples of how LiDAR is being used for forensic applications. So here we have a fly-through of a crash scene that was captured with the VZ400i and then processed through RIEGL. So this video itself was also done directly in RIEGL, and it can be used to help corroborate your witness statements, corroborate evidence from your scene, and help you revisit your scene throughout the investigation of the accident, the crime scene, the crash scene, whichever. This is also extremely powerful for juries during court proceedings, where this type of video evidence can actually be introduced and shown to the jury. So they can actually take this, show this on a television screen, and they can see the accident scene on the day of its occurrence through their own eyes and help recreate that picture, that image in their head of what happened. They say a picture is worth 1,000 words, but I personally think that a video is worth 1,000,000. Being able to show this to a jury in real time helps them understand what happened, what might have gone wrong. So this is important not only for law enforcement, but for prosecutors, defense attorneys, the court system altogether. So some other examples that we're going to be showing you are some crash testing from a conference we go to called IPTM. So IPTM stands for the Institute of Police Technology and Management. They hold a conference every year where they have a crash day. They set up different test scenarios and invite all of the attendees to come outside to watch crash scenes occur in real time and then watch investigators work these scenes with a variety of technologies. So here are some images of the first scenario that they did this past year in 2019 here in Orlando, and it was a semi-truck versus a sedan. So you guys can see here through just the regular images, the different points of impact, crash profile, things along those lines. So our first shot here is the data in true color. So you can see the clear tire markings where my cursor is right here from where the truck actually attempted to stop, as well as the impact damage on both the truck here and on the sedan. So if you switch the view type, go over to reflectance, you can actually begin to see the beginnings of the point of impact here from the fluid spillage and the markings in the pavement. So you can see where the point of impact was and how it pushed the sedan all the way back when the semi actually hit it. Pretty cool, if you ask me. So the second scenario of the day was where a school bus went against two sedans and won that fight. So as you guys can see from the picture, the attendees of the conference were very interested in watching the crash scenario. Honestly, at the risk of being punny, it's a huge hit to watch these happen. So these are the just general images of the points of impact from where the bus hit the vehicle. So you can see on both sides of the bus, points of impact, and then the damage on the sedans. So here it is in true color. So you guys can see here the shattered glass from impact, just spread out all over the ground. Scanner picks that up, no problem. We can see on the vehicle, you can see loads of damage. You can also see even markings for UAV ground control. So there was a UAV being flown on site that day, and so that way the UAV can pick that up with the total station later. And so in X-ray view, which is another view that we have available in RIEGL, you can actually help to amplify and highlight areas of the scene. So it just gives you another set of eyes and another way to look at your scene.
So as we said before, we were looking at scanning in adverse weather conditions. I want to say you might have seen this slide before, but it's still very relevant and it works beautifully well. So yeah, scanning in rain, yes, we can do it. Bear in mind the scanner's IP64 rated. And we record the rain. We also record the buildings behind. But what we don't do is filter any of this data on board either the scanner or on importing into the software. We allow you, the end user, the investigator, to have full control over what data it is that you filter, and thus you can justify why you've filtered what you have done. So particularly with rain, this is quite easy to detect and filter out. We can set certain parameters. The rain itself offers poor deviation and poor levels of reflectance. So once we know what those sort of parameters are, we can ask the software to look at those areas. And this is the rain that's been picked out in that filter. And once we've done that, we don't delete it, we just switch it off or turn it into another layer in the points cloud, so we can always refer back to it if needs be. And the end result is a nice clean data set from the scan, showing the information that it is that we want to show. So we've got rid of the rain. We can bring it back if needs be, but you know, most people aren't interested in the rain. They want to see what's behind it.
So at the end of it all, why would you use LiDAR for forensic applications? So the first point to me is the most important, is that you are using technology-driven tools to become more efficient in clearing your roadways. There are statistics out there that say that for every 45 minutes that a road is closed due to an accident, that the risk of secondary crashes increases exponentially. So using a technology-driven tool to get you in and out of a scene faster, to get a road cleared, to get cars back up and running, you are actually saving not only yourself time in the field, but you're actually saving the community time, possible accidents, additional loss of life, additional injury. You're just becoming more effective and efficient at doing your job. Obviously, we've talked about freezing the scene in time. You can go back and revisit the accident later that day. You can visit it tomorrow. You could visit it in 5 years if you need it. You can have that data available for your use whenever and wherever you would need it. Operating in a variety of weather conditions, as we've explained earlier as well, you can use it in heat, cold, rain, snow, fog, dim light, bright light, any sort of lighting condition, any sort of weather condition, the scanner is going to be able to work and work for you.
So it's important to note as well just how efficient the scanner itself is, which gives us the ability to conduct efficient investigations of fatal crashes or crime scenes as appropriate. This is important important even in police work, even though time doesn't necessarily equal money directly, but there is that always in the back of the head. The flip side of that, or the bonus side of that, is it provides increased safety to both law enforcement with a quick scene capture, whilst also increasing, as I say, commuter experience on the roadways. The road is cleared faster, thus reducing those secondary crashes that we've already touched about. The numbers are quite startling, actually, how quickly those crashes can result as roads are closed in an unexpected manner, such as following a crash. And of course, what we provide at the end of the day is scan data, which provides a more detailed depiction of the crash for court or criminal cases. So we know we're producing this for an end client who won't have visited the scene, won't know it from Adam necessarily, and we've got to present enough data so that they can fully understand what it is that they're seeing and what it is that has gone on, so that they can make an informed judgment.
So at the end of it all, of course, why Regal? So we've already gone over a lot of these points today. So, and you guys can see that there's quite a lot of text, so I'm not going to read it to you. You guys can read it yourselves, but we're just going to go over the big bullet points here. So the first one is that we're user friendly. Again, the one-touch workflows, touchscreen interface of the hardware, easy buttons to use in the software. We just want to make it as easy as possible, so that way every investigator on your team can use the software, can use the hardware, can go out and be deployed to a scene at any point of the day when it is needed. We have superior technology best suited for use in the elements. So again, we are the most productive laser scanner on the market. We have a range of up to 800 meters with the 400i. We have an IP64 rating, which is splash proof and dust proof. So this can be used. I live in Florida. I've used the scanner in the rain before. I'm still getting data, no problem. Superior maintenance. We are the most reliable. We have software that's valid indefinitely, and we can do service and repairs in our facilities, no problem. Technical support is another one we really pride ourselves on. Customer service is a really huge point of pride for the Regal brand worldwide. We love our customers. We want to make sure that our customers feel like they're family. And we have online resources available. We have training guides. We have manuals, modules ready to go for you to use. We have phone support, email support. Our support team in the US, we have extended hours. They're always available. They are always ready to help. That's, again, something we really do pride ourselves on. We have a good warranty when it comes to our scanner. You get a 2-year warranty included with the price. You get an expected life cycle minimum of 8 years. We have guys who have been using scanners out in the field. The older iteration of the 400i, the VZ400, we have guys that are still using some of the originals out in the field, and because they've stayed on top of their maintenance, are still fully up and operational, no problems. Deliverables, you have a variety to choose from when it comes to RISolve. You have your plot views, you have fly-throughs, you have visualizations, you can export to other forensic third-party softwares if you need to do any extra processing from there. So training as well, we have accredited training that's conducted by instructors with a law enforcement background, which is Dave. And we have standard and advanced sessions. So you can have your group go through an initial training, and then your advanced users, your bright stars, the ones that pick up on everything really quick, if you want them to go through an advanced training, we have that available. Cost-wise, we have an all-inclusive package for 2 years. That's hardware, software, training, all the extra peripherals that you need. And we have, and this is one I cannot stress enough, we have the lowest life cycle cost over time. Very important to note, because our systems are in the field for years. You want to be able to have something that you can rely on and go back to, and be able to know that you're going to be able to trust that system every time you take it out. So enough on that. We are going to open up the floor for questions.
Yeah, and we've got a few questions in. Okay, so to start off with, what are the specifications of the cameras attached? So we have the option of 3 different cameras currently. We supply Nikon D610, D810, and D850. The D610 is a 26 megapixel a 24 megapixel sensor. D810 is a 36, and the D850 is a 45 megapixel sensor. There are other nuances with each camera. For example, the range of ISO exposure time, exposure equivalents and such like. But all three of those are capable of working with the VZI series scanners, so that they can do the automated capture of the RGB values at the same time as scanning. Depending on the market, we offer two different lenses. There's a 14mm wide-angle lens and a 20mm wide-angle lens. Offer a slightly different field of view, but both produced by Nikkor, which is Nikon's lens manufacturers. Excellent pieces of glass. I mean, I like the 14mm lens. It is a superb piece of glass on the front of the camera. Yeah, it's those are the three camera options that we're offering currently. What we've got on here for the 8-hour scan. Yeah, we actually did that with the new lithium-ion battery pack, and we used well, it was just over 5. It was 5 and into a 6th battery pack for the entire project of those ones. The normal add-on round battery, which you may be used to, is around about 4 hours worth of use, 4.5, depending on how generous it is. With and then the no-cell brick battery is about the same, again, about 4 hours of use. So the advantage of the lithium-ion battery pack is it's a lot lighter for the same punch. Bob is asking, and Bob Boswell is asking, this is ground-based? Yes, it is. This is not a drone-based scanner unit. This is very much a terrestrial unit. There's some advantages and disadvantages for drone-based activities. Generally speaking, terrestrial laser scanners are far more accurate. They're much less weather dependent. You don't need to be a pilot to operate it. It operates, broadly speaking, in a much wider range of weather conditions. You aren't restricted in the same way you are with drone capabilities. Can you achieve a scan in 30 seconds? Yes, we can. We're going to drop down the resolution to 50 milligrees. If I go back to that slide, I don't know if I can go back on here. Let me just click back on here. Somewhere on it, there was. Go back a couple of shots. All this glorious technology. There we are. So if we look at this slide here, so can we produce a scan in 30 seconds? Yes, we can. If you're looking at the graphic on the right-hand side, this is the panorama 50 setting, 50 milligrees, 30 seconds, and that will also include the imagery. So yes, it's perfectly capable. 500 plus scan positions in your 8 hours. That, in terms of battery life, that's pretty much the same again. It's because your resolution is less, you're putting out slightly less power, so you put in more scans. It's pays of money, takes your choice really. And as you can see, the lower the resolution, the less time it takes. So, you know, as I say, the standard, if you like, default position at panorama 40 milligrees, that's 45 seconds. 50 milligrees, 30 seconds. Panorama 60s is only 25 seconds. And panorama 80, I wouldn't tend to use that very much, but it's an option. 19 seconds to produce that. Position. So let me just go and click back forward again. You can also see it again now. Right. Let me just have a look at some more questions because there's quite a few of them coming on here. So, oops, I've gone past Jill. I've shot them too far.
Give me a moment. My computer just froze. So going back. You guys gotta love technology.
Accuracy at 10 millimeters, the quoted accuracy at 10 meters, sorry, the quoted accuracy for all of the surfaces, we're asking black, grey and white surfaces, is quoted accuracy is 5 mil with 3 mil precision. Generally speaking, we're going to be better that, as shown by that forest area. The angular accuracy, I'd have to get on the data sheet, but it's pretty tight. And real weight, depending on which battery pack you put to it, it's around about 14.5 kilograms. If I get my phone out here, quickly convert that into pounds. So 14.5 kilograms, give or take. 14.5. So that's about 31.5 pounds. That's including that's everything, you know, if you carry it on the shoulder. So I'll come back to one of the questions from Aaron Kumar. I'll come back to that one. Can you achieve in scanning 30 seconds? Yes, I do. Will LiDARs, John Hubler, will LiDAR drones be used in recreation soon? Is that recreation? Reconstruction?
I will say this. We actually are having a few UAV webinars as a part of the Regal series in the next couple of weeks. Mylin would actually be to ask that question.
Yeah, so we do UAV drones, LiDAR drones, or the LiDAR packages for drones. So I'd say that will be coming up in this series of webinars.
Yeah, Mylin's webinar will actually be later this week. If you actually go to the Regal newsroom, which is newsroom.regal.international, it is our blog. We actually have a blog post up that actually shows all of the upcoming Regal webinars that we're going to be having. And it will have, I'm trying to pull up the exact date while we're talking, but she's got 2 that will be coming up shortly. So her first one will actually be in 2 days on the 23rd, which is the benefits and highlights of the Minivux series UAS LiDAR. And then her other one will be on April the 30th with Stephen, who is our ULS technical sales and integration specialist. And that will be on the Regal Vux series UAS.
Okay, does the software come as a package also with the VMX RI software package? It can do, but this is a static software package. It's designed for the TLS scanners, so the VZ400i, VZ2000i, and as Jill pointed out earlier on, it's formed from RISCAN, so it's part of the RISCAN family.
Yes.
No, I don't know when the next version of RISCAN Pro will be out. As soon as we have it, we will let you know as soon as possible.
Yes, as soon as a new version comes out, if you are registered in the Regal members area, you will actually get an email notification that will let you know that a new version is available.
So are there any need for any third-party add-on tools within RISOL for export coordinates in CAD as required in RISCAN Pro? Within RISCAN Pro, we can export in text format only. There is a tool that's common to both RISCAN and RISOL called the Coordinate Export Tool, and that allows you to export in ASCII or into AutoCAD versions as well as text. You also have an option of DXF object exports or line styles and point codes. And so they're all contained actually within RISOL itself. You can access it from the tools menu. If you go down to tools and then toolbar, it's in that area there. The maximum height of the tripod for general police and forensics use, we don't specify a maximum or minimum height. The maximum height is going to be determined on the stability of the actual tripod you have yourself, and also the ability for you to move it safely. I tend to train people that as long as the center of the screen is of the touch screen is at eye height, it will capture an awful lot of the data. The higher up you are, of course, the further you have reducing the angle of incidence, but you also enlarge the nadir gap in the underneath the tripod. Besides RISolve or in RISolve, can we offer any analysis tools to recreate the scene? So there are tools in RISolve to recreate the scene, as in reposition the vehicles. All the vehicles that you've seen there are all done within RISolve. If you're considering investigation tools such as crush analysis and those sorts of areas, then no, we don't do it. It will have to be exported into a third-party package for that sort of data. Next one, Sergio Garcia. I hope he's well across in Spain. How many different scan positions do you need for a standard two-car crash in an urban area to avoid as much shadows as possible? So we would normally recommend, depending on where the two vehicles are post-impact. If they are close together, you clearly can reduce the number of scan positions. Ordinarily, I would suggest for a standard two-car crash, if you like, at a intersection, you'd be looking something in the region of 8 to 10 scans would document that particular area. The trouble with saying how many scans it does relate to how much data there is on the scene. So we don't want to be prescriptive, and sometimes you may get away with less, particularly if there's no marks and all you have is two vehicles that have collided, no skid marks, tire marks or gouges or such like. Then you could arguably use less scan positions. So this is a question about the range of the scanner. So just to put your minds at ease, yes, Regal is normally known as being a manufacturer of long-range scanners, but that doesn't mean to say that we can't operate at short range either. The minimum range of the Regal VZ400i is 0.5 meter, which is as close as any of the manufacturers, I believe. So yes, the scanner is capable of both long range and short range operation. Next one, can the scanner be mounted on a drone? You're going to have to use quite a big drone with this because of the scanner.
We do have LiDAR units for the drones, but that would be definitely best suited for the MyLin webinars on the 23rd and the 30th.
Yeah, so next one is, after the scan, which software do we need for analysis like blood spot, bullet trajectories, etc.? So blood spatter analysis is quite a complex area. There are a number of software packages out there that will assist in that analysis. I wouldn't necessarily recommend one over the other, as I'm not, me personally, that is not my area of expertise, isn't blood spatter analysis. So I'm not going to be, I couldn't really advise on which software is best for that. Bullet trajectories, similarly, but that seems to be a much wider analysis. Again, there are a number of third-party software packages that are available to conduct bullet trajectory analysis. Visus Arena 4D, or there's not RS360, whatever its current version is, Farozone, sorry, for example, and a number of others as well. So next question, do you need to use a terrestrial tripod or can you use carbon fiber tripod? So yes, we can use a terrestrial surveyor's tripod, or we can use a carbon fiber tripod such as a Gitso, or we now supply as an option one made by Benro, which has is a very lightweight, can condense down into about 50 centimeters length, so it can fit inside our larger scanner box. So yes, you can use a normal terrestrial tripod or the carbon fiber tripods. Get my teeth in. Mobile scan data, no, it's not for this product. As I say, this is for a static device, so it doesn't mean the actual. It's not a mobile device. It can be converted to or adapted to use in a mobile scenario, but that requires different software because there are a whole lot of issues relating to kinematic scanning devices compared to static scanning devices. So next question is about on-site registration. So we are conducting, firstly the question is, what does it mean on-site registration, and is it ready to export to ReCap? So on-site registration is conducted on board the scanner in real time. So the example that we showed you there was 400 plus scans. I think we sort of noticed a little bit of a lag when we got to about 360 something, I think it was, or 370 before we actually sort of, there was a gap of maybe 1 or 2 scans starting to appear. You would have to bring it into the software to export into ReCap. So it still needs to be brought into RiScan or RiSolve before you can export it into ReCap. But yes, that is a registration. It's not a pre-registration, it is registered data. You may want to run a multi-station adjustment routine to block adjust the data, make it neat and tidy, especially if we are talking about a survey which has got a closed loop or something of that ilk. So next question is about thermal imagery. We can use some thermal imagery, and we do have a thermal and infrared camera available. Is it useful for forensics? It can be, depending on what sort of scenario it is. The thing with forensics is there's an awful lot of, to use the word forensics, it's quite a broad sphere. If I'm looking at crash investigation, which is a branch of forensic science, then thermal information is not necessarily so useful other than to determine items such as the road surface temperature. That said, you're normally not attending the scene until quite some time afterwards, so the road surface temperature may well have changed somewhat since the time of the crash. Other scenarios may have a different bearing. It would have to be considered, but it is possible to apply thermal infrared imagery to our scan data. Next one is, are there any limitations with the colour or surface from a car that may cause lack of measured points, and how to solve that? So this is the ubiquitous black shiny car question. The Regal scanner has been generally very good at recording black shiny cars. I'm not going to say they're perfect because no scanner is. The closer to 90 degrees you get to the surface, then the better is the return. So therefore you get a better quality return from those sorts of vehicles. So if you had a vehicle that was a black vehicle, then ideally the car should be quartered and scanned at the 90 degrees. So a bit difficult without showing a diagram, but at each quarter the scan should be positioned to show at front offside corner, centre front near side corner, centre near side, rear near side corner, rear centre, rear offside corner, and then centre of the offside. If that makes sense. I'll probably stick a diagram up about that. That's the best solution to that. It's making sure that you're as close to 90 degrees as possible to the vehicle to get the best return from the car. We did do a test probably 2 years ago at Spa in Los Angeles, where that test was specifically done. There was a black shiny car, or half of it was black and shiny, the other half was dusted in rubbing alcohol and essentially white powder, and the results were shown at the end, and we were pleased with the results. We knew we would be competitive, but it was very pleasing to see what the results actually were. Scrolling down, getting to right. In what platform the attorney would like to see the scanner evidence? That depends on the attorney. There are many would like to see the video or the scan data evidence delivered live. There are others that would like to have it delivered in a pre-recorded format. So that will be a question of liaising with the attorney as to how that evidence is to be introduced into the court. I know, particularly in American listeners may be able to correct me on this, but there is, I think is it disclosure, one of the two, where that the actual format of any evidence to be introduced, especially if it's in contention, would be discussed.